Hello, welcome to the presentation on Classes and Objects Part 3. Today's session we will see the following concepts. We will understand the mutable concepts in objects are mutable, copying versus aliasing, and str method. So coming to objects are mutable. See, objects are mutable in the sense we can change the state of an object by making an assignment to one of its attributes. So if you refer the previous program which we had done in the last session, the program on updating the dimensions of a rectangle and finding the center point, the link to this explanation of this entire program would be shared in the description box. So in this previous session we had created two classes. Just to quickly revise point and rectangle. So point is a class where it's going to where we are representing the points in 2D space, and rectangle we are going to represent the attributes width, height and corner. And we had three more functions, print functions. Basically this is a function used to just display the points x and y. Find center is a function which is going to find the center of the rectangle using the width and height as the inputs. So for this find center we were passing the rectangle, that is the object, as the argument. And we had one more function called as grow_rectangle, where we are passing the rectangle as an object, and also we want to grow the rectangle. So basically we are changing the dimensions of the rectangle. We can increase or decrease the width, we can increase or decrease the height. So in order to do that we need a value, right, to increase or decrease. So that is the delta value. So that we call it as delta width, d width and d height. So these are the arguments passed, and this grow rectangle function is used to modify the dimensions. Either you are going to add or subtract the width and height of the rectangle. So in this program we saw that basically there are two classes, right? So which are the two classes? Rectangle and point are the two classes, and box is an object of the class rectangle, right? And we are also creating an object called as point of the class point. Now objects are mutable in the sense what, after creating the object I can change the values of the object, box.width, box.height, as well as point.x and point.y. we can change it. That's why we say objects are mutable. So if you see in the program we have done modifications to the objects. See, for example, here in the in the main program we are displaying the width and height of the rectangle, and then we have called the grow_rectangle function. The function of this is to change the width and the height. In this function we have added 50 and 100, right, to the height and width respectively. So this is the value we are going to get after the updating the dimension. So if we execute, you can see here there's an error in this part. Okay, see the value of the width and height before updating. So this is the original dimension of our rectangle. Our rectangle is having a width of 100 and height of 200. After we call the grow_rectangle function, where I added 50 to the height and 100 to the width, you can see that to 100 we have added 50 and we got 150. To 200 we added 100, we got 300. So basically what we did here was we have changed the width and the height. And what is width and height? Width and height is nothing but box.width and box.height. What is box? Box is nothing but an object. So we have changed the attribute of a object, right? So that means what? Object is mutable, right? I have changed the attribute of the height and width of the object x. So that means object is mutable. In the similar way we have also changed the x and y, right? Box dot, as I have told in the last session, corner box is an object of the class rectangle, and in turn box has a variable called as object, which is in turn a object of the class point. Okay, so that is why it is pointing to this. This is also a class. Corner is a object of the class point, which is in fact one of the attribute of the object box. So object is pointing to another object. So we are also able to change the x and y dimensions. So the whole meaning is objects are mutable. You can change the values. You can change the state of an object by making an assignment to one of its attributes, right? Object was box and one of its attributes was height and width, which we changed like this. Box dot width is equal to box dot width plus 50 plus box dot height is box dot, this should be height, box dot height plus 100. So you can change the attributes of a object. Okay, and the similarly for rectangle also we did. Rectangle is also a class and an object of that was rect. Rect is an object of the class rectangle, and even that we changed. We changed the dimensions of the width and dimensions of the height. And this is the small part of the code where we demonstrated how the width and height of the object class box is modifiable. So this is a very frequently asked question for 6 marks in the V2 examination. So if you write this with some part of the code explained, right, and also better you write this diagram to say that this rectangle is a class, point is a class, box is an object of the class rectangle, corner is an object of the class point, and box dot width and box dot height is a attribute of the class of the object box. And you can see here that we are able to change this, and then you write this code. So that means objects are mutable. Okay, now coming to the next concept. Now there's a very important concept. They frequently, it is asked in the interviews as well as in the examinations. Copying versus aliasing. Now what is aliasing? Let's first learn that. See, aliasing means you have two and more variables referring to the same object in a memory. So you have a memory box, okay, and more than two variables are pointing to the same memory box. So that's the meaning of it. Okay, so that is aliasing. So for example, if you take this code, what is happening here? X is actually containing a list 1, 2, 3, and here in the second line I say y is equal to x. So basically what happens is, in the memory somewhere this list is stored, okay, and x is pointing to that memory address, and after executing the second line y is also pointing to the same memory address. Okay, so 1, 2, 3 is stored somewhere in the memory. X is pointing to it as well as y is pointing to it. So if you print x and y, what would be displayed? 1, 2, 3, 1, 2, 1, 2, 3 and 1, 2, 3. Both x and y will contain 1, 2, 3. Next, when I say y dot append 4, so that means to value y is initially containing 1, 2, 3, to that 4 would be appended. So now it would be 1, 2, 3, 4. Now again when I say print xy, the question is, y will definitely have 1, 2, 3, 4. What about x? Right? Would x have 1, 2, 3, 4? It should be having, because both are pointing to the same memory location. Okay, so both are pointing to the same memory location. It is something like this. So I have a memory location here. Suppose this is a memory where I am storing the values into it. Right? So here I am storing the values 1, 2, 3. And x and y both are pointing to it. X as well as y both are pointing to it. Okay, so this is x and you have one more, that is y. Both are pointing to it. So definitely when I say y dot append 4, the value will become here 4. Since both xy are pointing to the same thing, both of them should have the same value. We can, let's try this out in the Jupyter notebook. Okay, so let's go to the Jupyter notebook. Okay, let me create here. See what I have done here. X is equal to 1, 2, 3, y is equal to x. Now let's print x, print y. Now I will append 4 to it. Now let's print x and y and see what happens. You will see that before appending the value of x and y was 1, 2, 3. After appending, both x and y have changed. So that is aliasing, where both of them will point to the same thing. Now what happens to copying? Right, so that is why aliasing can make a program difficult, because changes in one place might have unexpected effects in another place. So you should be very careful when you are using aliasing. But what about, so an alternative is copying, because you don't know, right, when changes will happen. Somewhere in the code you make changes to x, and somewhere else thousands of lines of code y also will get affected. You can't really keep track. So an alternative is just copy an object but do not alias it. So you, for copying an object, you have a function called as copy. it will just create a duplicate. So how you do this? Same code has been altered like this. So instead of saying y is equal to x, what I will do is I will import a module called as copy, and then under this module copy there is a function called as copy. So when you say copy x, then the values of x would be copied into y, but they will not point to the same memory location. Okay, when you say copy, y will not point to the same memory location. So what happens in the second case is you will have the memory location as it is. X would point to this. X will still point to this, but y will not point. Okay, so what happens here is in copying, x will still point to it, but y will not point. Okay, y will not point to the, only x will point to this list. Okay, y will not point to it. So any updations you make in x, y will not get affected. So what I will do is I go back to this code. Instead of saying y is equal to x, what I will do is I will first I need to have a module called as I have copy. First import that, import copy, and instead of saying right y is equal to x, I will say y is equal to copy dot copy x. That's the only difference. Let's import this before. Okay, so what we have done now is instead of saying y is equal to x, I will say copy dot copy x, and when you execute this, you can see the output how different it is, right? X is I appended to y, and therefore 4 is appended only to y. It is not appended to x. Okay, so that's the difference between copying and aliasing. It's a very important concept. So please go through this. Okay, so copying is an effective alternative to aliasing. It will only duplicate the object, but they will not point to the same memory location. Now coming to the next concept, str method. Now when do we use this method? Now str is actually a method. As the name itself says, is a function, and the functionality of this Python function is to define a custom string representation of an object. So remember this method is used to define a custom string representation of an object. Now what do I mean by this? Let's go into Jupyter Notebook, let's understand, and then come back to theory. Okay, so what have I done here is, okay, I have created a class called as dog, and then I have written the init function. So what is init and all that was explained in the first part of classes and objects. You can go through the link that would be given in the description box. To briefly tell you, init is a special function which gets called whenever a new object of that class is initiated. So whenever a new object for this class will be initiated, this function will get called, and initialization will happen. Okay, name and age would be initialized, and always in init the first argument would be self. So in this init function, I want to initialize two variables, name and age. So that's why you're using the self parameter. Self.name is equal to name and self.age is equal to age. Now let's see this later. Now coming to this, what have I done here is, dog is the name of a class. So I'm saying dog1. So basically I am creating an instance of the class dog. So dog1 is an object of the class dog, and for this, as I said, init, whenever the object is created, I want this init method to be called, and there are two parameters you have to pass, name and age. So just give it here as an argument. So in C, actually we have C++, we have a similar concept. We call it as parameterized constructor, right? So what does it do? Automatically it will create an object and it will parameterize, it will assign values to the variables, right? So buddy is a name and 3 would be the age. Similarly, one more object I am creating, dog2, where Charlie is the name and 5 is the age. Now suppose I don't use str. So now what do I want to do? I just gave you a print dog1, print dog2. Now the question is, what would be printed, right? Dog1 is just an object which is created, right? So when I execute this, you see the output would be something like this. See, this is the output I am getting. What is it saying? Dot dog object. So basically it's just giving the information that it's an object at this memory location. The second one is also an object of the class dog at this memory location. So that much only it is saying. But I don't want. I want the print to be, I want to print the object the values of the object in a proper format. So then you have to go for str method. So what is str method? It's you write def, you're going to define a function. So write def underscore underscore str underscore underscore, and self should be the argument for this function. Return. What does this function return? I want to return the name and age. Okay, so what is this name? It's basically an object attribute, right? An attribute of the object. So you want to display the attribute of an object. So what you say, self.name. So what I'm saying here is within double quotes, self.name is self.age years old. So that means if it is printed, Buddy is 3 years old, Charlie is 5 years old. I want that to be printed. So then write here, right, this str function, right, within curly brackets. So basically that would be the placeholder, right? Self.name is self.age years old, and ensure that this is within curly brackets. This is basically the string formatting concept explained in one of the sessions. The string formatting session information also I'll give in the description box. So where I've explained the use of this f, explained the use of the curly brackets. So if I write this function, what basically happens is str function, it is a Python function which is used to display the object values in a string format. Okay, it is used to display the object values in a string format. See, when I execute this, automatically when I say print dog1 gets executed, this function is called, and it will replace the values here. It will replace the values of Buddy here, replace the value of 3 here, and it will print, what is it printing? Buddy is 3 years old, Charlie is 5 years old. Okay, so when I say print dog1, automatically str method gets called. So this is a simple example of str method. So to quickly revise, what is str method? It allows us to define a custom string represent, custom, because we can customize, right, how I want my string to, I can change this statement in any way I want, right? So basically it's a custom string representation of an object. So when you print an object or convert it into a string using str, it uses the default implementation. So suppose I don't use str method, this is what we saw, right? It's going to just giving us the information of the object. So when print dog1 was called, what happened? Python automatically uses the str method to get a string representation of the object. So str method will give the string representation of the object. And what happens without str method? It will print something like this: main.dog object art. So this is basically the memory location where that object is created, and .dog is the name of the class. So it's saying that it's a object of the class dog. So this is also a very commonly asked question. In V2 exams or any colleges, this is just asked for. Examinations, it's only asked for 5 or 6 marks, where you have to explain the concept and explain the diagram. Okay, so just a quick revision of different types of variables which we have been seeing throughout in all the parts of the part 1, part 2, part 3 of class objects we have discussed so far. We saw class variables. What are class variables? See, in the simple program, I have a class called dog. Canine, this is a class variable. Why? Because this variable is actually, species is a class variable because it is declared inside the class. What is instance variable? See here, instance variable is here, right? I have created an object here dog1, I have created an object dog2, and here I am saying dog1.name, dog1, dog2.name. So that's an instance variable, right? Any changes I make in dog1.name, it will not change dog2. It is like, see, for example, here I have changed dog1.name. Initially it was Buddy, I changed it to Max. So when I print this, only the dog1 would change, dog2 will not change. So that's the difference. But if you make any changes here, instead of canine I put something else, it will change, right? So here I'm saying dog2 dog.species feline. It is, you can modify it, but okay. So class variable is basically shared by all the instances of a class, but instance variable is unique to each instance. Example in this code, dog1.name and dog2.name. Example in this example, class variable is species. How do you access the variables? We access the variables using the object name or class name and dot operator. If you want to access the species, how do you access this? You say dog.species, class name dot species. How do you access the instance variables? Object name dot variable. Okay, you access the class variables with the class name dot the variable. To access the instance variables, object name dot the variable. Okay, so these are the different variables which we saw. So that was it. So today's session was a quick revision of why objects are mutable, what's the difference between copying versus aliasing, and str method. So any doubts or any kind of suggestions or queries you have, please let me know. Thank you so much, and please subscribe to the channel.